Welcome to lesson 7137, combining trigonometric and algebraic functions. Okay, so from the last several videos, this is a summary of the trigonometric functions, all six of them, the period, the domain, and we remember domain is all possible x values, everything you can input in for x. Okay, the range is the y values, what you get out, what you actually see. For the asymptotes, are there asymptotes? An asymptote is a line, a graph, or a function does not touch or cross. Or zeros, where's the function zero? And then odd and even functions. So let's talk about even and odd functions. So an even function means f of negative x is equal to negative f of x. So this is an even function. And what does that look like graphically? So graphically, the left side and right side of the y-axis are mirror images. So it has symmetry about the y-axis. That's what an even function is. Okay, so what does it mean for a function to be an odd function? So an odd function, why did I put on that? So an odd function means that f of negative x is equal to the negative of f of x. So odd functions have symmetry when you rotate a graph around the origin. So whatever on the right side of the y-axis is going to be flipped upside down and then flipped around y. So that's the difference between even and odd functions. So if I graph the sine real quick, it goes up, comes down, goes back up on the right side. But here's the y-axis. If I go down, then up. So we see that the sine is not even if I flip it around. If I flip it around y, it's not even. You flip it upside down and then flip it left. That is, or you rotate it 180 degrees. Now the cosine is even, which means if I flip the cosine around the y-axis, you're going to get a mirror image. So that's the difference between even and odd. Okay, let's look at the following thing. So they want us to change the viewing window to be negative 2 pi to pi and adjust the vertical window as needed. Which of the functions appear to be periodic? Okay, so let's look at A. I'm going to put this in the calculator and I'll draw the graph here. Okay, for A, so we put in the windows, x min is negative 2 pi, x max is 2 pi. We then change the x scale. We change the y min, so this is only for A. Our y min is negative 10. Our y max is positive 20. And we didn't change the y scale. And this is the graph we got. So it sort of looks like a parabola. It looks something like this. So this is A. This is not periodic. Okay, for B, we had to change y min to negative 25 and y max to positive 25. All right, so When you do that, this is what your graph looks like. It goes up, comes down. So it looks something like that. So that is not periodic. Okay, when we graph C, do not forget to close the parentheses. I forgot to say that with A2 a couple slides ago. So sin x, close the parenthesis, then hit the x squared button, and your graph is going to look like this. But we had to change the windows. Y min is -2, and Y max is +2. And then you get, so this appears to be periodic. So C is periodic so far. And let's see what the next one looks like. Okay, with D, we left the same windows as C. So leave the windows the same. And then you get this. All right, so as you get close to 0, the wave spreads out. And then you get further away, the wave crunches up. So this is not periodic. Okay, so let's prove this algebraically. Okay, the sine of x, not x squared, but the sine of x, the whole thing squared. So we know that the period of the sine is 2 pi. So the sine of x plus 2 pi equals the sine of x. Because it's periodic at 2 pi, every angle after 2 pi is going to equal 2 pi. So f of x plus 2 pi is equal to the sine of x plus 2 pi squared, because the sine of x plus 2 pi is equal to the sine, this is equal to the sine squared. And that is equal to f of x. So this is f of x plus 2 pi, and this is f of x, then everything follows down the line. Okay, let's look at example number 3. Now prove that y equals sine x equals y equals x cubed. Sine of x as a whole function equals x cubed. Okay, so f of x is sine x, and then we're going to use x plus 2 pi is equal to the sine cubed of x plus 2 pi and so this gives us the sine of x plus 2 pi cubed. The whole thing can be cubed, so the 3 moved outside. Since x plus 2 pi equals x, because of periodicity, this equals this, and this equals f of x. Back to the beginning. F of x equaled that and that. And you set them equal to each other, okay? Okay, let's start with A. Okay. Find the domain, range, and period each of the following functions. Sketch a graph of showing the 4 periods. All right, so the absolute value of the tangent of x means that all y values are going to be positive the domain is the same. It's all reals except the asymptotes. So the domain D is all reals except pi over 2 plus n pi, where n is an odd integer, the range. Now the range is going to change. Whatever negative values had now become positive. So it's going to go from 0 to positive infinity. So imagine the whole negative side of the graph flipped upside down. This is bracketed because it's included. Okay, that's taken care of. Now the period is still pi because that's the period of the function is still pi. So that didn't change. That's the, but it just happens to be shifted over pi over 2. All right, so domain, range, and period. Now we're going to sketch a graph. To sketch a graph, you take your calculator, so this is what it looked like normally to pi over 2. That's pi over 2. But instead of starting low, we start high and come down to 0 and then go back up to 3 pi over 2. And then at 2 pi, you're coming back down again. And these are asymptotes at every odd pi over 2. And this goes back up to negative pi over 2. And this is coming down at pi and going back up to negative 3 pi over 2. And you're going to use the windows x min negative 2 pi, x max 2 pi. And the y min and max is going to be negative 4 to positive 4. And that should give you a good visualization of the graph. Oh, you'll have to change your x scale to pi over 2. And that should give you the tick marks on the graph, on the x-axis. Okay, so now for the absolute value of sine x. Now, it went up to pi over 2 and down to pi. But instead of going over, it bubbles back up. So now the sine is always going to be positive because the absolute value is a distance and it's always positive. So we're at negative 2 pi and positive 2 pi, 4 and negative 4, and our x scale is pi. You can make it pi over 2. Doesn't make a difference. You should get the same thing. Okay, adding the sinusoid to a linear function. All right, so the graph of f of x, 0.5x. So this is a slanted line. Plus sine x oscillates between two parallel lines. What are the equations of the two lines? So the sine oscillates. It goes back and forth between 1 and negative 1. So if we have 0.5x plus 1, and then 0.5x minus 1. These are the two lines. So we're going to do like this and do like this. And you can graph this in the calculator. So if we call this (0.5x plus 1), and we call this line 0.5x minus 1, the lowest and highest values that the sine could be, then the sine is going to do something like this. It's going to go back and forth.